Okay, so welcome to, let's see, class 1, and this is an in-class exercise that I wanted you to do. And for those of you who maybe didn't show up to the first class, these are things that I'm going to be asking you to do, to upload stuff during class for in-class assignments, and that's part of your class participation grade. So what we want to try to do is do this problem right here, sample problem 2.1. We want to find the resultant, but we want to use this like online module here. Try to get used to it. It's kind of an interactive thing. Let's see what we could do with it. It's a nice little tool to play around with. So we have 60 and 60 newtons and 40 newtons, and they're at the P at 40 newtons is at 20 degrees, and Q at 60 newtons is at 45 degrees, and we want to find what the resultant is to adding these two vectors. So we're going to use this online tool to try to approximate it the best that we can. Right. So I say, just warn you that you're going to need to use a scale factor because of the way that this thing's set up. So this is from this project called PhET, and I don't even know what that stands for. But let's see. It didn't load the thing up, but maybe it's going to come up. It's going to load it up. There you go. And you could do this on your phone. I think this will send you to the right place. I hope. Otherwise, we'll have to send you something else. And you have a couple different things. We will use these again in other classes. Here you go. I want you to use. Well, no, what did I tell you to use? Let me see. Let me see what I said. I said to use the Explore 2D. Is that true? I might have changed my mind. It might be Lab. Let's see. Let's go to the Explore 2D and let's see if I'm going to change. Yeah, Explore 2D. That'll work. And let me put myself up, no good place for me right now. I'll put myself right there. All right, so I'm going to take A. All right, so I'm just grabbing this vector and I'm going to move him. I can't put him any place. It doesn't really matter. But I want this A. Let's say that this is going to represent our force. Let's say Q, right? Let's make this Q. So Q needs to be 60 newtons and 45, right? But it's hard. You can't fit 60 with the scale on here. So let's divide it by 60 by 5, right? And so that's going to be 12. And we need it to be 45. So right here, the best that we could do, like at 45, we think at 11.3 right here, right? At 45, it's kind of easy to see, right? That it has to go diagonally like that right there. And I could get 11.3 or I can get 12.7. All right, I can't get anything better than that, not with the scale factor I'm used and the amount of discretion here. So let's take B and let's put him right there. We're making that triangle. And that's supposed to be what? 40, right? 40 divided by 5 is 8. And it needs to be at 20 degrees, right? So 20 degrees is kind of like there's 8. There's at 14 degrees. There's 8.5 at 20.6. I think that's the best that I'm going to be able to do, right? Is that right there. What I could do, though, is I could hit now this button up here, the sum, right? I also maybe want to put values and angles onto this right here. And I can drag these over to there, right? So now if you wanted to get what the answer is, like, so that's what the triangle looks like, but let's put, this is the triangle that results from these two vectors, but let's just look over here and we could see that the answer is 20.8 is the predicted magnitude. But notice that we made these larger than they should have been. They were all 12.7 and 8.5, so we anticipate this to be larger than it should be. If we multiply now that 20.8 times 5, we get 104, right? So what we predicted with this online utility here is an answer of, I don't know if, will this let me write on the screen? I don't know if it does. Let me see. Nope, it doesn't let me write on the screen. But let's see. I'll put a little thing right here. See, what I do is I will put him over to the side over here, if it'll let me. And will it let me draw? Only brush? Yeah. I would say that what I've predicted is that R is going to be approximately, so 20.8 times 5 ends up being 104, right? And the angle that I have represented right here is, whoop, my calculator just fell, 35.2 degrees. Right. So that was the entirety of the in-class exercise. And what I would want you to do if you were, let's say, if you were on your computer to do this, I'd ask for a screen capture. And so I just screen capture this, or if you're on your phone, you just do the screen capture where you I don't even do I have my phone with me? I think my phone's downstairs actually. That's so far away from your phone. But anyway, and then just upload this. And so that's going to be like some of the in-class types of exercises to try to make sure that we have this engagement, to try to give you a feel for what's going on. And I'll have other things in that throughout the semester where I want to watch you give you an assignment during class and do that. So anyway, that's what we had for today, and that's only a 6-minute video. But I'm going to add all these up and see how the timing of the class is one of the reasons why I'm making this. But also, I want you to have as many resources as possible. So thank you.